Teaching Chemistry with Science-Based Digital Simulations by Courtney Lowe and Shanna Weaver. Chemistry is known as the central science. A fundamental understanding of basic chemistry concepts is at the heart of most other sciences, and yet students do not study chemistry until high school. Abstract concepts, such as those included in the Georgia High School chemistry curriculum, can be difficult to teach. In fact, Chen and Howard's 2010 article states, "Scientific concepts are complex, highly technical, and often considered among the most difficult subject to teach K-12 students." As difficult as the concepts may be to the teacher, they can be even more challenging for students to understand and master. For example, students cannot see atoms, subatomic particles, or chemical changes at the molecular level. As a result, student interest and engagement in the chemistry content can be negatively impacted. The purpose of this study is to explore the effects of technology integration, specifically science-based digital simulations, on student mastery of the Georgia chemistry curriculum. Digital simulations are computer programs that attempt to simulate a model of a particular system. Simulations allow users to manipulate the model, view the outcome of the manipulation, and visualize scientific concepts. Furthermore, simulations allow students to safely explore and experiment with what-if scenarios. Generation Y, the population ranging from age 5 to mid-20s, has grown up with technology. Research indicates that Generation Y frequently uses technology to gather and produce information. They are learning with technology. Using simulations, which have been shown to enhance students' active engagement in the learning process and are associated with gains in conceptual understanding of scientific concepts, can supplement the chemistry curriculum and lead to increased mastery of the standards. This study will address the following research questions. What are effective pedagogies for integrating science-based digital simulations? How do students interact with science-based digital simulations to learn abstract concepts? Do science-based digital simulations? This study will be conducted in one high school teacher's chemistry classes. It will take place for the duration of the semester. One teacher's classes are being studied instead of several teachers' classes to protect the integrity of the research. Using only one teacher will ensure that the instruction material presented and assessments are consistent throughout the classes. The main difference among the classes will be the student interaction with science-based digital simulations. The teacher has 4 sections of chemistry, which will participate in this study. 2 of the 4 classes, A and B, will use science-based digital simulations to aid and enhance instruction. Classes A and B will have individual access to science-based simulations through tablets. The other 2 classes, C and D, will not have access to science-based digital simulations. Instead, classes C and D will participate in traditional approach, which includes various hands-on activities and simulations shown by the teacher. This study will be primarily qualitative in nature, though it will incorporate the quantitative method of comparing testing data. A survey with a 5-point Likert scale will be used to measure the teacher's perceptions about the use of science-based digital simulations, effective pedagogies for using the simulations, and how it impacts student achievement. Students in classes A and B will also take a 5-point Likert survey that will assess their experience and preferences as it relates to using science-based digital simulations. Students in classes C and D will take a different 5-point Likert survey, which will measure their experience in a traditional science class. The researchers will also conduct observations to determine the teacher's pedagogy for integrating simulations in the chemistry curriculum and to observe how students will use the simulations to construct knowledge. The teacher and a small group of students from each class will also participate in pre- and post-study interviews to reveal their perceptions and experiences, which may not be addressed by the surveys. All students will take the same assessments throughout the study, including pre-tests and post-test for each major unit of study to determine the impact of the simulations, if any, on student retention of abstract concepts. The research plan for the study is summarized in the table. As you can see, this study will be an extremely thorough and comprehensive look at the impact of science-based digital simulations on the chemistry curriculum. The study will include a variety of techniques, assessment instruments, and will require multiple methods of data analysis. We expect the results of our study will help us determine effective pedagogies for integrating science-based digital simulation, how students interact with simulations to learn and retain abstract concepts, and what impact the simulations have on mastery of the chemistry curriculum standards.